So for condensing logarithms, that's when you have more than one logarithm. They have to be the same type, but then you combine them into just one logarithm. So notice I've got more than one logarithm. I'll be able to write it into a single logarithm. More than one becomes a single one. So that's the idea behind condensing. You take a bunch of logarithms and condense them into one logarithm, or at least less. Now, if you look this up in the textbook, it's going to write it, the properties these two ways, and then we'll do it with numbers. But it says if you want to condense, you need your logs to have the same base, so base 3, and then when you condense, it's going to have that base. So these are base 3. When you condense, it still stays base 3. And the first one says if you had like some number b here, some number c here, and you had a subtract in between them, that condenses with division. So the first one becomes your numerator, the second one becomes your denominator. So subtraction condenses into division. So subtraction condenses into division. Now, this is not the other one, but this is where it does get kind of confusing for some students, so I'm just trying to give you a preview of what kind of landmines you need to worry about here. But when we expand, we're going to undo this. So we're going to start with something like this, and we're going to expand it to look something like that, which is not the same thing as saying you could just change this sign and expect this to work. That's not true. You can't just switch those. If it's subtraction separating multiple logarithms, it condenses into division. But division is not a type to condense. So that one doesn't work. So be careful thinking that it works both ways. The other one says if you had two logarithms of the same type and they were separated by an addition sign, you could condense those with multiplication. So for us, number 2 here, log base 3 of 5 plus log base 3 of 2 could condense to log base 3 of 5 times 2. But of course, we know what 5 times 2 is, so let's just go ahead and change that to 10. So again, there's a few small things about how we want to write our answers, but really that's all the properties say. Subtraction between multiple logarithms condenses into division. Addition between multiple logarithms condenses into multiplication. If you know those two, those are the only two ways you can condense. All right, so to give you a heads up of where we're going with this, because this section focuses on expanding and condensing and reviewing some of the stuff from 3.2 that you may not have thought about since the break. But then when we get to section 3.4, it's all about solving equations. So this would be a great problem. Number 3 would be a great example for how this is going to be used. So trying to come up with some number so that log base 5 of that number plus log base 5 of 10 equals 2. It's just not something that you can really do in your head. You also just can't use the skills just from section 3.2 because we talked about how to evaluate this, but this is not a nice whole number. So I guess you could round it in your calculator and kind of move forward that way. But sometimes this is an example of where condensing is necessary. You'd say, okay, well this is log base 5 and this is log base 5, so I can condense them into a log base 5. If they were separated with addition, then I can condense those with multiplication. And now I've rewritten it. Now I know you probably haven't thought about logarithms in a couple weeks, but we did solve some like this. This is logarithmic form. If you switched it over to exponential form, it would basically be solved at that point. Okay, and reduce. So the harder solving questions will expect you to condense questions like I just did there. But you don't need to worry about that just yet. I'm just trying to show you that it is important. Okay, so expanding is really just the opposite. So if you know condensing very well, expanding is just the exact opposite. So if you had a single logarithm with division inside, you could expand that to multiple logarithms with subtraction. If this was a subtract sign, you couldn't expand it to division. It doesn't work that way. Division expands to subtraction. Subtraction condenses to division. Okay, so again, what I'm really saying is, just to make the connection here, sometimes we start with this as the question and this as the answer, and then now we're saying this is the question and that's the answer, going just the opposite direction. Okay, so if we do this on question 4, we're going to get multiple logarithms. This is log base 3. When you expand it, they stay log base 3. They don't just magically change to something else. The numerator goes first, the denominator goes second, and if it was division inside, then when you expand it, it'd subtract. And that's really all that property, but you know, if you see something that simplifies like this, you should remember this is saying 3 to what power gives you 3. So you should know that changes to 1. So go ahead and do that. Okay, and then the second property, or undoing the second property, would be if there's multiplication inside, you could expand to addition.
And since it's it's a property, it could go either way, right? Like you could put that x above a 9 first because it's.
For this one, you can, because the order of addition doesn't matter. 5 plus 3 is always 3 plus 5,
Right.
But subtraction does matter.
Right.
So that one does have to go in that order. Yeah. So these are being multiplied. So log base 3 of 9 plus log base 3 of x, and there they are expanded. Now again, I'm trying to highlight what you should be looking at here. If something simplifies like log base 3 of 9, you should just change that to 2. That's just saying 3 to what power gives us 9. Okay, and then an example of how this would be useful to you, and you can use this one in the book assignment that we'll get to here in about 10 minutes. But I did have you work some questions that look similar to this before the break, and what you had to do before the break, and you're still welcome to do, by the way, but you had to think of this as exponent rules. An exponent of -4 in the denominator is the same thing as an exponent of +4 in the numerator. And then 4 is an exponent on something we're taking the log of, so 4 can come down out front. Seven to the first gives me 7, so it looks like the answer to this question is 4. So that's the way we did it before break, because we didn't know how to expand and condense. Okay, but now you've got an option. I'm not saying that it's easier, but it's something that you can consider. Because now we could say, well, we've got division inside a log, so what if I expanded it out? So it'd be log base 7 of 1 minus log base 7 of 7 to the -4. This evaluates to 0. This -4 you would need to bring down. It's an exponent on something that you're taking the log of. Log base 7 of 7 is 1, so you end up with 4 times 1, and you can see you get the same answer. Now again, some of you are going to think this is easier, and that's fine. But I'm just showing you that if you know expanding, you could rewrite it, and you potentially could think that this is easier. Sometimes expanding and condensing is necessary, sometimes it's just helpful. Sometimes you might think it's a better option. Okay, so the stuff that we did before the break on inverse functions, you know, it's good to know that, but it's not really going to hold you back in this section. what we did in 3.1 with exponential functions, also I help you know and remember, but it will also not hold you back in this section. 3.2, we did logarithmic graphs, which won't apply too much here. There's maybe one time where it's helpful to remember what a logarithmic graph looks like. But that being said, some of the properties from 3.2 will still be used. So things like how I'm bringing this exponent down, and I know how to evaluate this and know that this is 1. Those type of things are still going to be used a lot. So again, when we jump over to the bookwork in a few minutes, I think like the first half of the assignment is really just good review of that stuff before you even get into expanding and condensing. Okay, so you need to know that when condensing, at the end, you should go ahead, or not at the end, at the beginning, you need to move these coefficients up as an exponent. And what I mean by that is, if I had given you a minute to try question 8, what I think most of you would do is you would say, okay, log base 3 becomes log base 3. Subtraction between those condenses into division. The problem with that, this can't be our answer. The mistake that you would be making that's easy to do, and I can tell you guys calculus students do this too, because we do lots of logarithm stuff, but we don't ever get to just focus just on logarithms. You're kind of expected to know that. You're just ignoring this 2 out here. You can't just pretend like that 2's not there and then like tack it on later. It doesn't work like that. So before you can condense, you need all these coefficients. This is a coefficient. It's being multiplied by the log. Bring this up as an exponent. So 99% of the time you bring it down as an exponent, but occasionally you want to bring it up. So it's not log base 3 of 5 over 2, it's log base 3 of 25 over 2. That 5 is supposed to be squared. So before we apply those expanding and condensing, well, I guess it's just this way. Before we condense, we need any coefficients to come up as exponents. We need them up out of the way so we can apply the property. Okay, and then if we expand, at the end of the question, we want those exponents I don't know how I did that. Okay. We want those exponents to come down as coefficients. Okay, and so what I mean by that is, if I ask you to expand this, I'd hope you would do log base 3 of 9 plus log base 3 of x squared. This was 9 times x squared, so they get expanded with addition. I would hope that you would just rewrite this as 2. Anything that comes out to a nice whole number, you should just do it. But over here, none of the answers are going to look like this. If we gave you a multiple choice question, which we've been doing a little bit more of lately, or you see it on the ACT, or you check your answer in the back of the book, it's not going to look like this. They're going to expect, if you're going this direction, to bring your exponent down as a coefficient. So if you look at number 8, its question is kind of like what the answer should look like if you were expanding. And if you look at the question for number 10, that's what your answer should look like when you're condensing. So bring the numbers down if you're going that direction. Okay, so I've got a couple quick ones for you to practice. So take 60 seconds here and write down what you think you should do for 11, and then we'll check and see if that's good. And then I'll give you another 60 seconds to try 12, and then hopefully catch some of the mistakes you may be making. So for question 11, we've got two natural logs, so you could condense those into a single natural log. But before you apply the property, again, you can't just ignore this 3. You can't pretend like it's not there. You really need to bring it up as an exponent. Now I've got the natural log of something, subtracting the natural log of something, and that's what you're aiming for. Subtraction between logarithms condenses into division. Yeah, did you have a question?
No, you answered it. I was thinking like whenever you moved it up, why it wasn't -3, but then I realized it was subtraction between. Yes.
Okay, so make corrections there. Obviously write yourself a note. If there was something you didn't think of, word it in a way that makes sense to you. And then take a minute for number 12. But I will tell you number 12 is a little tricky. But I want to give you the opportunity to see if you would catch the common mistake or not. So I'm not too concerned with the first step, especially since we were just talking about it. I would expect all of you to have natural log of the numerator minus natural log of the denominator. Division inside a single logarithm expands into subtraction. But why is this not the final answer?
Because you have to bring the exponents down, so it would have to be, isn't that right?
Nope.
You still have to expand the right one into two addition, or addition.
Okay, good. So do you see that this will still expand? Is that what you're going to say? Okay. All right, so because this is natural log of something times something, so we could expand it with addition. Okay, you brought up we do need to bring the exponents down, so let's do that. Bring the 2 down, bring the 2 down, bring the 3 down, and that's still not right. So what we did right now is a little harder because it's a little bit longer, but we still haven't touched on the common mistake and the reason why I threw it on the notes. Any guesses? Okay, it's right here. This was minus this whole thing. So yeah, I split this up, but I can't just start saying, well, let me just minus the first part automatically. It's still minus the whole thing.
You put parentheses.
Yes, you need parentheses, and either keep the parentheses there, or if you don't want the parentheses there, it's going to change this sign because it needs to be distributed. So what you could do is if you leave this as a plus, take this answer, try to condense it, and you're going to see that your z to the third would be in the numerator. With this being a minus, the z to the third goes in the denominator like it's supposed to. So be careful. I think you really need to try to show this to yourself somehow. subtract all of this, still subtract all of this. Don't just magically make it minus the first half and plus the second half. Okay, first few homework questions or book assignment questions talk about change of base. So we did talk about that a little bit before, but just coming up again. So reminder, if you wanted to evaluate log base 3 of 7, you could do it with common logs, which means base 10, as log of 7 divided by log of 3. Or you could do it with natural logs, which would be natural log of 7 over natural log of 3. And then if you needed a decimal, you should be able to type in either one of those, and they give you the same thing. So you're still on the hook for that formula. Now again, make sure that you know both ways. If you only care about this decimal, it doesn't matter if you type this in or this in. But as a multiple choice question, we might make the answer look like part B, and you only may ever type it in your calculator as part A. So then you could be setting yourself up to miss that. So I would suggest that you just think of it both ways anytime you need to use it. All right, and then finally the last tip that will be helpful for our homework is if I ask you to expand this, this is 7 times the square root of x. So multiplication inside expands as addition, but the answers aren't going to look like this because the roots, square roots, cube roots, fourth roots, are really exponents. So a square root is an exponent of a half, a cube root is an exponent of a third, a fourth root is an exponent of a fourth. So because this can be thought of like that, we wouldn't leave our answer looking like this. We would need to bring the 1/2 down. And again, when you're checking your answers, if you just have a square root of x here, and this doesn't have a square root of x and there's a 1/2, you need to understand why theirs looks different than yours does. Okay, so if you would, get out a blank piece of paper, jot the assignment down.